Well, thank you for that very gracious introduction. And it's great to be here, and it's great to welcome all of you to my now new home. I've been here for 2.5 years, and it's a wonderful place to be, and it's great to have ASLO back here in Victoria. And here we go. So, British Columbia, from glaciers to oceans. And as we've heard, the theme of this meeting is Water Connects. And water connects, as we know, our social systems, our ecological systems, in very many complex and important ways. But what I want to talk to you about tonight also is the importance of climate change in adding another complex layer to our aquatic systems. And also pointing out throughout my talk, I hope, the need for bringing together the natural sciences across all the disciplines there, as well as with many other groups, including policy analysts, economists, architects, as we'll see later in the talk. Basically, all dimensions of the research that goes on. And also the very important part of that being done in collaboration with those that can make decisions about how to address climate change. So I'm going to use British Columbia as an example in this talk. But before we get too serious, I'd just like to remind everybody where we are and put it in a little bit of a context. So many of you I know have come from very far away, across oceans, across continents to get here. And you may be quite jet lagged, some of you. So let's just kind of zero in on this here and remind you that you're in North America. You're not in the United States, you're in Canada. And we're actually located, of course, in British Columbia, the westernmost province of Canada. Also, we're here on Vancouver Island, and you've probably now are aware that Vancouver Island and Vancouver City are not the same and not in the same place. In fact, we're here on the very southern end of Vancouver Island, in Victoria, of course, and the blue dot shows where the University of Victoria is, and the red dot is right here where we are downtown at the Convention Center. So, now you know where you are in the big scheme of things. But I'd like to take you on a photographic journey to begin with, starting from the glaciers in British Columbia and moving all the way down to the oceans and into also the social systems that we have here. So I'm just going to go through some of these beautiful photographs of British Columbia, from glaciers through our aquatic continuum. And it's not just, of course, the beautiful nature that we have around us, but the human dimension of the province as well. Here we have the MICA Dam, which is the second highest dam in North America. We'll come back to that later in the talk. Large distances of travel needed in the province. Forestry being a major industry here, as well as mining. Agriculture, including vineyards. I hope you all have a chance to enjoy the British Columbia wine while you're here, as well as a major port we have in Vancouver, and right here, the provincial capital in Victoria. A diversity of people from many parts of the world, including the Chinese, who have been very important in the development of the province from the beginning to today. The Prime Minister of Canada, Justin Trudeau, and of course, very importantly, we have 198 First Nations here in British Columbia, and as we've heard, a very important process of reconciliation. This is the raising of a reconciliation pole at the University of British Columbia last summer. But as beautiful and wonderful as British Columbia is, we're not immune from climate change. And climate change is affecting all of our aquatic systems and is going to be affecting aquatic systems around the world. And so how is British Columbia dealing with this and addressing this? Of course, it's very important that Canada is on board with solutions for climate change, because Canada is warming at 2 times the global average rate. And this is a map of Canada, and you can see British Columbia on the far left-hand side, and you can see that already we have areas that are 2 degrees, have warmed by 2 degrees, and this is from actual measurements over the past about 60 years. And some areas are also even reaching up into almost 3 degrees increase. So we need to be particularly attention to the issues of climate change here. The province, in the province, we're very fortunate, and over 90% of our electricity is from hydropower. However, that's only 1/3 of our energy use. We still have major emissions of greenhouse gases because 2/3 of our energy is still fossil fuel. The province has very progressive legislation about climate change and reducing climate change. I'll just point out that we have a legislated reduction of 80% in our emissions by 2050, and a whole suite of other policies which are being put into place. But let's now go on a journey from our glaciers down to the oceans and look at some of the ways that climate change is affecting our aquatic systems, or maybe in the future. We'll start up at the top with the glaciers. You can see in blue here the area of glaciers in British Columbia. And the area of glaciers and volume in British Columbia, plus a little bit into Alberta, is actually greater than that in all of mountainous South America, and even greater than the Himalayas. So we have major glaciers here, but they're retreating. And we're going to talk a little bit about the Columbia River Basin, one of our major river basins in the province. A lot of it, though, is in the United States, so we share this basin with the US, Washington, Oregon, parts of Idaho. Hydroelectric power being very important. A major dam up here called the MICA Dam. We'll talk a little bit more about that. But the glaciers in that area are rapidly retreating. You can see here over about a 4-year period, the decrease in about 5 glaciers in that region, in the Columbia Basin, and the cumulative decrease being about almost 2.5 meters of water equivalents over just a 4-year period. Not only recent decreases, but expected increased continued decreases in the future, regardless of the scenario of which we follow in the future. All the way from a very aggressive scenario of mitigation, RCP 22.6 by 2100. Even at there we have major decreases, as well as in business as usual scenario, somewhere between 70% to essentially all of our glaciers disappearing by the end of the century. And that's going to have important implications for our hydroelectricity and for our ecosystems. This just shows at the MICA Dam what the change in glacial discharge is anticipated to be, with an increase in discharge because of increased melting, followed by a decrease down to almost 0 again as those glaciers disappear, regardless of which scenario we're talking about. So that has some implications, of course, for hydropower, although it is only a small portion of the total flow into the dam or out of the dam. In addition to that, of course, there's runoff due to precipitation. And this graph at the top shows the seasonal variation in water flow into the MICA Dam. And the black line is the current flow. And there's a wide range of global climate models have been used to look at the future conditions up to about 2050. And you can see that we're expecting a shift in the flow to warmer, because of warmer, wetter winters, into the more early spring instead of the peak being in the mid to late summer. And then a decrease, of course, in the mid to late summer as we have very dry, warm conditions. So all of these combined have not only implications for hydroelectricity, but also for the ecosystems in the downstream rivers, implications for agriculture, as well as tourism and other factors in the province, as well as beyond, including across the border because of the extent of the watershed into the northwest part of the US. And of course, it's not just hydropower and the streams, but also tourism is being affected by having warmer, wetter winters. And many of you have probably been skiing here in British Columbia. But we're also starting to see a lack of enough snow in some years to support the ski industry. Similarly, as has been seen in the northwest in the US, as well as into Colorado and other places as well. And in 2015, in fact, a number of the ski areas closed, but these ski areas are also thinking about how they can adapt. So how they can adapt to this changing hydrology that we have. So they're developing indoor activities in the wintertime that are not associated with needing snow, as well as increase in the tourism in the summertime. So it's really bringing together understanding the hydrological system as well as the social dimensions here. Well, let's move down the watershed now a little bit away from the glaciers and the higher altitudes to our forests. Here in British Columbia, the forests cover about 2/3 of the province, as you can see here. And they're very important in terms of an industry. Our forestry industry is very important here. But also, as we know, forests are very important in retaining water, keeping the soils moist, decreasing the runoff and flooding, as well as decreasing erosion, as well as a source of organic carbon to our streams, as well as keeping those streams cool from the canopy that covers them. But we can also think of the importance of our forests in terms of carbon storage, carbon as a carbon sink. And as we know globally, forests and terrestrial systems around the world are responsible for removing about 30% of the anthropogenic emissions primarily into forests, the remainder going into the atmosphere or into the oceans. And so British Columbia has been thinking about how we could better manage our forests to increase the amount of carbon stored. And there's sort of 3 buckets that can be considered. One is better management of the forests themselves, all the way from selective harvest to fertilization. Another bucket is how to retain more carbon from forests in long-lived wood products. Instead of having it go into paper and pulp, which has about a year lifetime, have it go into more structural things for buildings. And then another important component in the management could be substitution effects. Instead of using fossil fuel, using wood for bioenergy, as well as instead of using steel and cement, using in some cases long, large pieces of wood for building buildings. And there's now a 16-story wood building at the University of British Columbia, just across the way here. And so this project has been looking at what are the various options for increasing the carbon storage through a variety of approaches. And what we have on the X or the Y-axis here is the percent change that various approaches to managing the forests and the products could have on reducing our greenhouse gas emissions here in BC. And so you don't want to look at all these different scenarios, but just look at the one at the end. And because the one at the end has the largest amount of CO2 being removed. In fact, this scenario, that's that 35 number, if you follow it across to the y-axis, would account for about 35% of our emissions in British Columbia being removed in the forest sector in one way or another. There would be some increase due to the production of wood products, but that also would be offset by using wood products instead of fossil fuel or to produce energy or for producing steel and cement. But the biggest reduction comes from better management of the forests themselves. And the net effect of that increase, the orange bar, and the decreases would account for about 35% of our emissions. So a major potential there. But our forests are not only stores of carbon, but of course they can be sources of carbon. And as many global climate models have predicted or projected, that many areas in the world will be experiencing more wildfires of a higher magnitude in terms of intensity as well as an extent. And in 2017, we had a record-setting wildfire season here in British Columbia, as was in also much of the northwest of the US and in other parts as well. It had the largest area burned, as well as the highest costs of any event of this magnitude in British Columbia. And tens of thousands of people were displaced from their homes. It also had serious health effects, bringing in the particulates in the air for those with respiratory problems. And even here in Victoria, the sky was so filled with smoke that for days on end we could hardly see the sun. And that was true throughout much of the northwest of the US as well. So, changing the landscape, changing the hydrological cycle as well in these areas that had been burned. Not only in terms of our streams that go through those areas having increases in temperature, which would be fairly short-lived until the fire was gone, but what's left behind is a denuded area, which now can have increased erosion, increased sediment input into the streams and rivers, as well as a lot of sediment and affecting the rivers themselves, as well as, of course, the communities that are flooded by this. So we're having some also unprecedented floods here in British Columbia this spring as well, due to a number of factors. But already you can start to see how we need to bring together, architects, engineers, policy analysts, people who understand stream ecosystems and the effect of various changes in those systems together to understand the impacts of climate change and how to address that. I want to turn now just briefly to outside of British Columbia from an example that I think has been very well done. It's on Boise River in Idaho, in which they've been looking at the combined effects of wildfire and climate change on these cold water trout habitats. What they've seen is that over a period of about 13 years, there was in this region of the Boise River about a 0.4 degree increase in temperature of the water. But in the areas that had experienced wildfire in the past, that's the gray regions that you see in this map, the temperature increases were 2 to 3 times greater. And that really decreased the suitability of the habitat because of the increased temperature. So that we really need to and the increase in temperature there above the average was due primarily to the loss, of course, of canopy cover shading these streams. We're also, of course, seeing temperature increases in our streams and rivers here in British Columbia. The Fraser River, a major river coming into Vancouver, has a mean, maximum, and minimum increase in the temperature over the last 50 years. And one of the sub-regions of that, the Nicola River, which is a cold water river and is an important trout fishery for anglers, has had exceeded the temperature threshold in 8 out of 10 recent years. So again, affecting not only the ecosystem, but the people that depend on that for their food, including the Nicola First Nations community there. Well, now I'll turn a little bit further downstream, eventually, but also to one, of course, of my favorite topics, at least from the past, which is nitrogen, as we heard, and a study that has been looking at the effect of climate change, in particular the precipitation changes due to climate change, on nitrogen loading to rivers. And we're going to talk a little bit about the Mississippi Basin, as you can see here. And what they have plotted here is the annual mean change in precipitation as well as the extreme in the sort of business as usual scenario to the end of the century. And the blues indicate an increase in temperature, and the areas that are stippled, if you can see them, are areas where the 23 global climate models that were used in this study agreed in the change and in the direction of change. So the more robust results there. You can see that the annual mean had more robust results than the extremes with these 23 models that were downscaled, of course, spatially. But now, what is the effect of this increase in precipitation on nitrogen input to the river? And we can see here that there's been the predicted significant increase in nitrogen loading throughout much, especially of the northeastern part of the basin, as well as some in the northwestern part as well, mainly due to the mean increase in annual increase in temperature, in precipitation in many parts of the basin, so that could have effects on the ecosystems in those regions. In addition, they have estimated what the effect of this would be on the total nitrogen export by the Mississippi into the Gulf of Mexico. And as most of you, I think, probably know, the Gulf of Mexico has a very large hypoxic area due primarily to the nutrient loading from the Mississippi into the Gulf of Mexico, and with nitrogen being a major component of that, of course. And the Environmental Protection Agency has a target of a 30% reduction in nitrogen use in the watershed in order to reduce the area and magnitude of the hypoxic area in the Gulf of Mexico. An interesting component of this study that we're looking at here suggests that the increase in precipitation in the basin, which will be increasing the nitrogen input to the river, will result in needing to actually not just decrease nitrogen use in the watershed by 30%, but actually having to decrease it by 60%. So again, noting the importance of understanding the biogeochemistry and the engagement with management in terms of making decisions that can be effective. Just have a couple of more examples, I see it's counting down, so we're fine. Moving now to our coastal systems. And we started with glaciers. We went to forests, we went to streams and rivers and the coastal zone. And now we're coming into coastal communities in the central coast of British Columbia. Very important First Nations communities living there, and also very important giant kelp forests that are part of their traditional territory. These communities rely on the giant kelp forests for food. It's an important economic component and very important to their social and cultural values. They had been approached, as I understand it, by a commercial kelp harvester that wanted to be able to harvest the kelp. Kelp is a very important source of algin. Algin's used in a lot of food products, all the way from ice cream to cereals and even in your toothpaste. And so they had approached, as I understand it, these communities to see if they could use those kelp forests to harvest for getting algin and other things. A study that was undertaken by some scientists at Simon Fraser University here in British Columbia to look at the effect of harvesting and changes in temperature on the recovery of the kelp from the harvesting. And there was a natural variation actually in temperature across these 5 kelp areas, 5 communities with kelp forests, from about 12 degrees up to a little over 12.6, so about a 0.6 increase in temperature. So a natural variation in temperature. And what they found was that the areas that had the lower, cooler temperatures recovered much faster from the harvesting than did those at the warmer temperatures. So this provides some information, and they've been working very closely with these communities, provides information to these communities they can use to make decisions about whether they're going to allow commercial harvesting by outside groups, and where and when that harvesting they might allow to take place. It also provides some additional information in terms of what they might expect as climate change continues to roll out and increases in temperature occur. Of course, it's quite complex. There are many factors that can come into play here, but it's, I think, a very interesting and important example of, again, bringing together the social and the ecological components of our aquatic systems and into a management framework. And my final example is what was called the blob. And the blob was an area of a region of very warm water, unprecedented warm water, that started off the coast, that was here off the coast of British Columbia, in the blue dash circle there, starting in the fall of 2014 and extended into 2016. The temperature was about 3 or up to 3 degrees or more higher than normal in this region. There's been quite a bit of work trying to understand where this water came from and how it was set up. It appears to have originated in the North Pacific. It appears that it wasn't actually an increase in temperature, but rather a lack of vertical mixing in the summer that would cool down normally the surface waters. Cool down those surface waters from mixing of nutrient-rich and cold, deeper water up into the surface. But what happened apparently during the summer of 2014 was that the winds, the storms were much less than normal in that region of the Pacific, so that this warm water from the summer was not mixed out by the nutrient-rich, cold, deeper water. And so as that water then moved into shore along our coasts, we had a major effect on ecosystems here. The water was very nutrient deplete because it didn't have that mixing of deeper water into it, so that primary production was greatly reduced. There was a major and unprecedented algal bloom, toxic algal bloom of pseudonychia, which occurs here normally, but not at the massive amounts that were seen in that year. The whole food chain in the surface waters was modified because of the decrease in primary production. And, for example, the auklets did not have enough food, and there were massive die-offs of the Cassin auklet, die-offs of many sea lions as well. And it's also thought that it may be in part responsible for the decrease in some of the salmon that are now being seen. The salmon live as adults offshore, and their food resources probably were compromised during this time, and may explain to some extent anyway the decreases in the salmon that are being observed now. So, British Columbia, from glaciers to oceans. I hope I've given you, some idea of the current changes that we're seeing here in our aquatic systems. Some of it can be attributed to early climate change. Some of it is more the type of things that we would expect to see more often as climate change progresses here. But I hope that I've also shown the importance of not only all of you coming together to address within the context of the research that you're doing, the considerations of how climate change might also be adding complexity to what you're seeing, but also the importance of talking with, working with, thinking about all the other factors that come into play, and the collaborations that you might think of developing with people entirely outside of the range that you've been collaborating with before. And also, very importantly, looking at ways that you can help to communicate and engage with people who are responsible for making the decisions in terms of managing our aquatic environment as well as our communities. So with that, I hope that you have a wonderful week here, that you thoroughly enjoy Victoria, that you have a chance to get out and see the wonderful, not only the city, but our surrounding areas. Go see whales, go see the seals, have a wonderful time here. And please talk with each other and learn from each other. So thank you.